So my name is Anissa Morrison. I'm the summer research intern at Mizzou, and I'm working with Dr. Mosa in health informatics. This is my first research experience, so I just have plenty of coding experience and a little bit of experience analyzing data, so this seemed to fit my skills. So I'm able to work with large data sets. So I've been looking at electronic health record data to find or to look at the risk factors of CINV, which is chemotherapy induced nausea and vomiting, which is one of the harder symptoms of or side effects of chemotherapy to deal with. And it's hard to treat once you have it. So many people are looking into informatics methods in order to treat it or predict who will be more likely to have it so they can treat it before it happens.
First of all, you need data to do research, and then data has to be, data has to be generated or obtained. So you can do prospective studies. That means you do clinical trials. There are other different methodologies to collect data in a prospective mechanism, like you do survey, different way to collect data from people, and then analyze the data and come to a conclusion about your hypothesis. The other way to see what data is available in the real world setting. So people call this real world data. And one of the largest resource of such data is the electronic health record data. That means patients are seen in the clinic, patients are hospitalized, and billions of clinical observations are recorded during those clinical interactions. And those are called observational data and very highly resourceful. But asking question utilizing those data and creating conclusion utilizing those data may not be straightforward. So requires different set of computational techniques, different set of methodologies, and still you could be able to answer a lot of clinical questions that might cost you billions of dollars and may not be even feasible given the resources that we have in hand in terms of people as a resource, in terms of other resources that is needed for research. So observational data, real world observational data, is a large set of this data, and that's where the health data science is playing a big role. And the future, we are looking into bridging the gap to come to a place where we can generate artificial intelligence from the data and apply those intelligence into the clinical process, into the treatment process for people.
There's just a lot of potential things you can find in a large data set because from just by looking at it with the human eye, you can't really see patterns. If the data is so large, you might have some anecdotal evidence like, oh, this person got this and then they had this side effect, but you don't really know the large patterns. So using the data sets, you can I use a program called R, where you can play around with the data set and filter it by this or do statistical analyses on it. And the usefulness of this is that you can do testing on the data to see if there's a correlation between one variable and another variable. And you can code this in R, so it will generate results for you. You just have to kind of do it right. There's a lot of finicky things. But once you do that statistical analysis, it will tell you how significant it is. So you can say like, oh, there's this like loose correlation but it's not significant, so like it's not really telling us anything. But we can actually find things and be like, oh, we know this is related to this. This predictor is related to this outcome, and we know because the statistical tests tell us.
So for me as a mentor, one thing I had to do, this engagement is for 2 months. And the student may have interest to stay engaged longer, do more research down the road, but how can we make these 2 months productive, not only for my lab perspective, but also from the student perspective, that what she can produce, what Anissa can produce for her research, so that it becomes useful for her career. Um, so that's one thing we focused on, that how we can do something achievable in 2 months. So first few days what we did is we talked and we we decided on something that is attainable, that is achievable. And that's one thing I learned, because this is the first time, as I mentioned, that I am mentoring a short engagement student. And like, how we set up a project that is achievable for her based on her experience, her knowledge. At the same time, she can achieve something that she learns, and at the same time she can come to a conclusion.
What excites me about medical or biomedical research is that we work to improve patient treatments and outcomes, and I think that's a super cool way to benefit a lot of people. So many people are doing research like this to try to improve medicine and know what treatments work or don't work, what treatments are better, more cost effective, things like that. The big data we work with really helps with that, and you, um, it the bigger implication is that it can benefit a lot of people in the future as we work towards improving things.